The biggest challenge is there are a lot of inquiries coming in simultaneously, so it's hard to sort of keep, respond to everyone right away. But actually, it seems to have gone fairly well. The biggest thing that's needed in the sort of short term is the ability to sort of gather all the data, create a very precise timeline, so that by the millisecond we know what each sensor was reading, and we can correlate that with ground video. And actually, like, one of the biggest challenges is matching the things to the exact time. Because when you're talking about a matter of milliseconds, being able to say, what is the ground track video compared to the data as received by the by the ground station from the rocket, and then taking into account for the actual time taken to generate a packet of information. When was that sensor read? When was it encoded into a packet? And when was that packet sent to the ground? When you're dealing in milliseconds, all that stuff actually makes quite a big difference.
Yeah, sure.
So that's the biggest sort of effort we've been engaged in thus far, is just putting together a super detailed timeline, and then just making sure that we have the sequence of events down as precisely as possible. That's what we've been working on. And but actually, certainly with the interaction we've had with NASA and with us, it's actually been quite good thus far. And we've explained that this is what we're doing, and then we very much welcome any feedback or input or review of the data that would lead us to a better understanding of the circumstances.
I thought we had a very
space transport, advanced space transport technology to the point where, get as far along the path as we can to where space travel is hopefully commonplace at some point in the future, and where we can send large numbers of people and cargo to other planets. And it's like that's the sort of thing that needs to happen for humanity to have a great future in space. So we want to keep pushing that. And I think, like, key to that future is reusability. So that's why we've worked quite hard on reusability. Unfortunately, we haven't succeeded yet. And in fact, the last launch, ironically, was we actually had the best chance of landing the vehicle on the sort of drone ship that's keeping station in the Atlantic. So we were actually quite sort of geared up for hopefully this would be a really great launch, and unfortunately ended up being the opposite. Well, on my birthday, of all things. It was a real downer.
You'll remember it, though, probably.
Yeah, it was definitely low point. But I do think in the future launches that we've got a decent chance of landing on the ship and then bringing the boost stage back to land. And then the next challenge, of course, is trying to figure out how to efficiently, effectively reuse it. And it is designed for easy reuse in theory, but we've got to see what the stage looks like when it comes back in one piece. Mm-hmm. We have been able to, over the last few years, do a number of vertical takeoff and landing tests of hardware that's essentially in the flight configuration. So we know we can handle the terminal phase. If if things go right, we can take off and land, no problem. So it's just a question of completing all the pieces, and hopefully later this year we'll be able to do that. But that's key. So, but of course that doesn't address upper stage reuse, but it addresses boost stage reuse, which is sort of 70% to 80% of the cost. But I think would be a great step towards lowering the cost of space transport.
So, if you look at your history
about helping to solve the sustainable energy problem, so we're trying to make progress on that front with those companies. With SpaceX, it's trying to help solve the kind of spacefaring problem. I mean, I think that a future where we're a spacefaring civilization and a multi-planet species is a very exciting, inspiring, awesome future. Mm-hmm. And in order for that to happen, we've got to dramatically improve the cost of spaceflight. and that's why SpaceX exists, is to try to lower the cost of space flight, which we've made some progress in doing, but still I would call out improvements thus far evolutionary, not revolutionary. But with a lot of continued work, I mean, I think there's the potential for order of magnitude or greater improvements. Reusability being key to all of that, of course. And then hopefully, if we want to, if we can keep improving the cost of space flight, then eventually, if that trend is in the right direction, it could be leading to a city on Mars, and certainly along the way, a lot of activity in low Earth orbit and the moon, and lots of other exciting things.
So one of the things we're trying to do with the International Space...
More reliable than the crystal ball. I mean, I don't really like risk for risk's sake or anything. And I do think that a lot of things are very risky with a low chance of success. But if you want to try to come up with an innovative breakthrough, that's going to be how it is. Anything which is significantly innovative is going to come with a significant risk of failure. But if you've got to take big chances in order for the potential for a big positive outcome. If the outcome is exciting enough, then taking a big risk is worthwhile.
Yeah.
That's really how I approach it. But then once executing down a path, I actually do my absolute best to reduce risk, because, or to improve another way of saying it, to improve the probability of success, because when you try to do something that is very, very risky, that you have to spend a lot of effort trying to reduce that risk as you embark down that path. I mean, when I started SpaceX, I thought the odds of success were very low. I thought we'd most likely fail, but I thought, well, we should give it a try nonetheless. And then I'm not sure if you know what preceded SpaceX, because or why I got into the space.
Well, I remember you trying to purchase a vehicle too from our Russian colleagues.
Yeah, that's right.
What you're talking about? Yeah.
Well, actually, it was the reason I got into space was to try to increase NASA's budget.
Well, God bless you then.
So I'll tell you, so the roundabout way I thought that might be accomplished was, I thought, well, if NASA's budget was larger, then we could do more in space exploration. And I thought, well, particularly if we could get the public excited about sending people to Mars. And I thought, well, if I could do a small greenhouse and send that to the surface of Mars with seeds in nutrient gel, and you hydrate the gel on landing, you have a little miniature greenhouse, and then you'd have, the public tends to get excited about precedents and superlatives. So it'd be like the sort of first life on Mars, the furthest life's ever traveled, and you get people sort of excited about, well, but maybe we should send people there, like the hell with plants, we should send people,
Right.
And then I thought, well, if that could get the public really excited about sending people to Mars, then that would translate into congressional support for a bigger NASA budget. That was the goal. And then I didn't have enough money to buy. And I thought that outcome would have a 100% chance of no commercial success. So the 100% chance of losing all the money. So compared to that, SpaceX, which I thought maybe had a 10% chance of success, that was an improvement. Disagreements here and there, but overall, I think we very much agree with the way it's being done. Yeah, I think it's pretty good. I mean, there are a few things where, it seems like the amount of sort of mass and volume reserved for poop is too high. Sorry, I don't know if that's but that's there's like little things like that. We're like, well, are they really going to do that much poop? But it's quite large volume, really. It's but really they're pretty small disagreements. So I think that it seems to be pretty sensible. And then we did the launch abort test earlier this year, which at the Cape, which actually went pretty well. Yeah, so things are going along, getting pretty exciting. Yeah, I think there's also some potential use for Dragon 2 as a science delivery platform. Going to sort of delivering payloads to Mars or other places. We're in discussion with other parts of NASA about some of those ideas, because the propulsive landing, it could really lower the cost of getting science instruments to various places in the solar system. So it's kind of exciting.
So I'm going to come back to that in just a second. But commercial, the crew
is the ability to do a propulsive landing, and it's basically having heavy thrusters on board. So those same heavy thrusters can then do the abort but retain the engines. So instead of in a normal sort of crewed mission, like say take the Soyuz for example, they'd have a tractor motor on the nose of the vehicle that would have to be, or basically a rocket engine on the nose that would have to be discarded on every flight, which is a potential reliability issue, and then you have obviously unable to reuse the abort system, and and it adds bunch of mass. But then in addition, those same thrusters can be used for propulsive landing. So you can achieve a precise propulsive landing, which on land or water, which is I think a significant improvement. I mean, it's sort of also it's sort of like it really I think feels more like the future to have that capability. And then as I mentioned, it can be extended to do payload delivery to the moon or Mars or other places because of the generalized capability of propulsive landing to land almost anywhere.
Very good. So let's go back to Dragon. At one point,